Hi everyone, and welcome to our video on the introduction to trigonometric functions. So trigonometric functions are defined based from the unit circle. So on our unit circle, let me just kind of squeeze that right up here, just a small one. We know that after a value, t value goes in, so some length around, so there's our t, we get a terminal point that I'm going to mark in the black ink, some terminal point x comma y. So, and it depends on what quadrant we're in for the length of t. So that's what they're saying is our terminal point based on t. So that's just the picture of it. And then they say, well, this is so important for us, we should just name those x's and y's functions. So they say the cosine of that value of t. So this is cosine of t is how we would say that. They're saying the cosine of that value of t is just the x coordinate of that unit circle terminal point. So cosine of t is x, that x coordinate. Okay, so let's even mark that for this. So that's the x coordinate of the terminal point. I'm going to abbreviate a little bit. There we go. X coordinate of the terminal point. And then they say the sine of t, so this is, it looks like sin, but we would say that's an e. Sine of t is how we say that. They're saying that is the y coordinate of the terminal point. These are our biggest two. So cosine of t equaling the x coordinate, sine of t equaling the y coordinate of that terminal point on the unit circle. And then we have four others. So the four others are based on cosine and sine. So this is tangent of t, tangent of t is how we would say that. And it is the ratio between sine of t over cosine of t, or the y coordinate over the x coordinate. So however way we want to look at it. So tangent of t is sine of t over cosine of t. Then we have secant of t. Secant of t is how we say that. That is the reciprocal of cosine. So it's 1 over cosine of t, or 1 over the x coordinate. Then we have cosecant of t. So that's how this one gets said. Cosecant of t is how we pronounce that. And these are functions, so that's why we have the of t. So we don't just say cosecant equals. We say or sine equals. It's always like sine of t or sine of something. Same deal with this one. Cosecant of something. So this is cosecant of t is 1 over sine of t. Okay, so it's 1 over sine of t or 1 over y. And then our last one is cotangent. Cotangent of t is how we would say that. That's the reciprocal of tangent of t, so 1 over tangent of t, or cosine of t over sine of t, or x over y. Okay, so the main two again, cosine of t is the x coordinate, sine of t is the y coordinate, and then these others tag along. We just need to make sure we know how to make the ratios. All right, so you've got these different ratios, and now I usually just make a table when doing these problems to help me out with those ratios, and I just kind of gets ingrained where they go. Okay, so in this problem it says the terminal point P, which is negative 2 radical 6 over 7 and negative 5/7 on the unit circle is determined by T. Okay, so let's just show what they mean by that in our picture. So they're already giving us the terminal points. So determined by t. Because both of those are negative, it means our t value does put us somewhere in quadrant 3. Okay, so I don't know exactly where it is, but there's what they're saying is the terminal point. So that is the negative 2 radical 6 over 7, comma, negative 5/7. And then they're saying find the 6 trigonometric ratios at t. So they're saying find cosine of t. And then I'm going to set up a table like this. Sine of t. And then tangent of t. So let's do those three right there. And then give a little space to the right. and we're going to write the reciprocals next to them. So cosine of t and secant of t. So secant of t I'm going to put to the side right there. And then we're going to put cosecant of t to the side of sine of t. And then tangent of t's reciprocal is cotangent of t. So the ones on the left are kind of like the big three, really the big two, cosine and sine. And then all the other four are based on the cosine and sine answers. All right, so what they're saying on this problem is, well, cosine of t, again, that is our x-coordinate right there. Or let's mark it even on this. There's the x, there's the y. So they're saying, well, cosine of t is that exact x-coordinate. Just write in that numerical x-coordinate, -2 radical 6 over 7. So that's all they say. That's all it is right now. Okay, so cosine of t is that x-coordinate. Sine of t is the y-coordinate, -5 over 7. Just like that. Okay, and then now we need to find those different ratios. Let's do the tangent of t. Okay, so I didn't mark the y on that. Let me mark it right there. There we go. All right, so our x-coordinate, y-coordinate. Now the tangent of t is the y-coordinate over the x-coordinate. So there's the y over x. Now it's going to get a little messy. Maybe I didn't give myself enough room. Let's find out. But the whole y-coordinate is the numerator, so -5/7. The whole x-coordinate is the denominator, so -2 radical 6 over 7, just like that. Now, this would need to get simplified. Well, what's going to happen every time, even if we do it the long way, is the denominators, these small denominators, the 7 and the 7, those denominators are always going to be the same in this setup of tangent. And what's going to happen is they always cancel. So that 7 would cancel, that 7 would cancel. And then also notice that we do have a negative divided by a negative. So the two negatives would become a positive. So what we're left with is positive. So the 5 in the numerator is still going to be there. The big fraction bar is still there. And then the 2 and the radical 6 is the leftover down below. Okay, so that's how that always works. Now, what they're going to want is for this to be rationalized as the denominator, rationalize the denominator. So they're not going to like this as a final answer. We need to rationalize it. I'm going to do that scratch work right here since I'm a little out of room. So we're going to rationalize the denominator, scratch work for that scenario. So we have 5 over 2 radical 6. All you have to do to rationalize a denominator is to multiply whatever the square root is on the bottom and the top. So the square root of 6 was down there. So we do the top and bottom multiplied by the square root of 6. And what's going to happen with that is the radical 6 and the radical 6 right there down below becomes just regular 6. Okay, so the square root of 6 times the square root of 6 is just 6. Up top, 5 and radical 6 is just 5 and radical 6. And then we said those highlighted became just regular old 6. So square root of 6 and square root of 6 is 6 when multiplied. And then, well, 2 times 6 is 12. So we would do 5 radical 6 over 12 as the final answer there. Okay, so sorry, I wrote those a little too close if you were writing too big like I did. Let me move the cotangent of t over just a little bit because I wanted to squeeze in that tangent answer. So there was my scratch work to get it. It did simplify to be 5 radical 6 over 12. Okay, so there we are. Okay, and then now the easiest way to get these other three. Okay, so they're reciprocals. So let's add that one little note right here. So these three functions, those three functions are reciprocal functions, which means all we really are doing is flipping. So remember, reciprocals is to flip the fraction. Flip fraction. So that means the secant of t is the flipped answer of cosine of t. So it's saying put the 7 in the numerator and the 2 radical 6 in the denominator. And then it was negative, so keep it negative. So that's it. That's all you have to do. Negatives we usually just keep up top, or in the front. We usually don't put them in the bottom. So the negative you can move around. Okay, however, just like our tangent of t answer, we would have needed to rationalize this denominator. So I'm going to show that in the blue right next to it. And then we would have, so I'm going to simplify this to be -7 radical 6 in the numerator. And then notice again, the radical 6 and the radical 6 would become just 6, and it would times 2. So 6 times 2 is 12. Okay, so there's the secant of t answer. Then cosecant of t, all we have to do is flip the sine of t's answer. Okay, so it's the reciprocal of sine of t, so that means flip the 5 and the 7, keep the negative. Our cosecant of t is -7/5. That's it, it's done. And then the cotangent of t, again, we want to flip the answer. Now, back to this, I'm going to star those. Those two answers are the same. One was rationalized. However, what I'm going to do is take the one that I'm double starring. Let's flip that answer. Okay, so that would be 2 radical 6/5 if we flip that double starred answer. Now, the reason I chose that over the single starred is because if you do flip the single star, you would have a square root of 6 down in a denominator. And they don't like that. They don't like square roots down in denominators. If we did choose the single star, it would eventually simplify to be this final answer anyway. So we're just saving a little bit of time. Okay, so that is how we break down our trig functions given a terminal point. Okay, so for now, that's I'm going to put a pause on it. Okay, so that's it. So thank you for watching. We'll pick it up again in a different video, our next problem. And if you do have questions, please let me know. See you next time.